Hi guys, Jerosh here. Welcome to our lecturing tutorial presentation on design development and conceptual process in architecture, part 2. For those who didn't experience part 1 content and would like to watch it, just go visit our Facebook page or our YouTube channel. You will definitely find it there. And others who have already gone through part 1, to those who want to say welcome to part 2. Part 2 is just the continuation of the agenda we set up in part 1. For this fact, we will talk about other design features attached to the design development and conceptual process in architecture. Without further ado, let's dive into it. For a better understanding and clarity, I will adventure into a 3-minute recapitulative briefing retake of the previous session, in which we cover the 3 first parts of our agenda. I clearly remember we enumerated 3D block modeling. We went throughout the building implementation, in which we touched the climate, form and orientation, the wind exposure, the site zoning conditions, and the solar radiation. And the third point, we talked about the floor plan sketches, which incorporate the pre-sketches, the post-sketches, and the final sketch. On the 3D block modeling, we enumerated different materials architects use for conceptual modeling, such as foam boards, metal. In metal, we're talking about aluminum, all type of sort of metals that you can find out there. We're having a transparent material, plexiglass, which is used for curtain walls, or railings, or sometimes even windows. And we speak about the plywood and cardboards for the shape, the wall framings, the wood itself used sometimes as well for the roof or walls as well, the foam and the polystyrene, and finally some little surrounding elements. We talk about the building implementation, which is characterized by the climate, the form and orientation, the wind exposure, the site zoning conditions, and solar radiation. We defined the climate as the weather of a particular region average over a period of time. It's a specific environment. It can be a city or it can be a country, it can be in a hostile environment. To understand that the climate plays a very significant role in architecture and building shapes, and in particular produces a number easily detected effects on architectural form. We talked about the different climate one can find, which is tropical, arid, temperate, and cold. In this, we understood that even the material selection of a building is influenced by the climate. Form and orientation. Building form refers to shape or configuration of a building. Orientation of a building is interpreted as a system of settings in rightful direction of a plan, in such a way that the building maximizes the benefit from natural elements such as sun, wind, and rain. So the building has to be set up in a proper orientation so that nature may induce it with its all aspects. Architects have to understand that nature has the ability to define the shape of your modeling, your design modeling. Wind has been for centuries an essential major natural element for the survival of human life. And hence, architectural design too. Wind plays the role of proper ventilation in the built spaces, commercial building, domestic environment, housing, etc. The first circulation of wind in the building depends on the interior structure, meaning the wall partitions. The ventilation parcours of wind in the building can be single-sided, cross-ventilation single spaces, cross-ventilation double banked spaces. After we roughly touch the zoning, we define such zoning as a set of laws or codes that dictates the rules for what one can build on a property. It defines how tall, meaning that in height, a building can be in a certain area, how much land it can cover, and what its functional purposes will be. Finally, on the solar radiation, we took example of a building located in hot climates, full of sunlight. And naturally speaking, we understand that the building will undergo tremendous heat radiation due to its position and location, which is openly to the sun. However, the shape and direction of the building may reduce the area of glass affected by sunlight, and if the glass field shaded, the need of artificial cooling will be reduced. Therefore, that is a major optimization in energy saving and again in cooling energy. And on the third point, we talked about the floor plan sketches, on which explain and decorticate what are called by pre-sketches, post-sketches, and the final sketch. For today's agenda, we will talk about the building material selection and the building element details. Number 4, building material selection. We have to understand one thing, that when it comes to building material, there are a lot of, there's that variety, incalculable number of materials that are used nowadays for building construction purposes. And the thing is, among them, there are some of them that are antique, I will list up like stone, brick, cement, lime, and timber. Those materials are traditional materials used for constructions for several centuries. As we are advancing in time, scientists and engineers are discovering new materials that are more flexible, with low density, and able to fulfill multitasks. And most of them are utilized for the higher-rise buildings. A building material is any material that can be used for construction purposes. It commonly includes wood, concrete, steel, cement, aggregate, bricks, clay, metal, or stone, even lime. And there are so much more that I'm not gonna list here, because we are able to write a book, a full book of 500 pages, just talking about material composition and building material. But for the purpose of this session, I'm not gonna go to the details, of what building material is about. I'm talking about the chemical property, the geological property, or the physical property, because that's not the purpose of this video. But I will definitely make a video specifically talking about building material, the density, of material, the porosity of material, whatsoever physical or chemical element that constitute the property of a specific material. I will definitely cover it in another video. Building material selection is an ordered process by which engineers can systematically and rapidly eliminate unsuitable materials and identify the one or a small number of materials which are the most suitable for a specific type of work or project. Material selection is crucial to the successful engineering and architectural design process. Designers and engineers aim for more strong and long-lasting possible products in order to maximize the values in reaching clients' needs and expanding their notoriety in other industries and worldwide. Dangerous failures arising from poor material selection are still an all too common occurrence in many industries. Therefore, safety implications are highly to be considered while selecting adequate material for the realization of specific tasks. We have to understand that material selection is a chain. There is no specific time at which you select a material, or you finally decide this is the material I'm going to use. There is not, the design in the beginning is unpredictable. The design during the 3D, computer modeling is unpredictable, and even before the documentation. So the material doesn't have a specific time you choose it. You can choose concrete in the beginning and end up with the floor timber wood before the design, the documentation. I remember when I work on a mechanical part, if I'm designing a mechanical component, the first thing to think about is the material selection. That's the first thing. I can have the overview of the mechanical part in my mind, the all shape and form as an idea or a vision. But to bring it to pass, I have to select a specific material identical or materials legible to it functioning, so that replication might not be a point of destruction from the product I'm trying to build. Because most of mechanical parts, or most of mechanical components, they need strength, they need stability, they need performance. There is a stiffness that intervene, and duration is the most important because I want my product to last. So the material selection is the crucial part of any design. It might be architecture, it might be mechanical, electrical, you name it. If you wrongly choose your material, you are betting to the downfall of your product. So selecting an adequate material to fulfill a specific purpose, it might be in the domain of mechanical architecture or in any domain, it's very crucial. It's very important and necessary to the accomplishment and the realization of your plan. So I think I will recommend designers, I will recommend architects to use more of their time in being able to implement and select the adequate material needed to fulfill the purpose. If you're having lack on material selection, I guarantee you start working on it. I guarantee you start planning, start learning, start digging in to find out the core and the ways that will allow you to make cool designs and product that's not only feasible but as well durable and sustainable for a long period of time. And there are a few steps for the materials selection process. First of all, you have to identify the design requirements. What's your design need, how your design is, how are you forcing your product coming to pass, which element are you going to use, what is the shape, the orientation, and all those things we precedently enumerated. Then you have to identify the materials selection criteria, which material criteria, in criteria, we're talking about the properties of the material, physical properties of the material, chemical properties of the material, and why not geological properties of the material, to help you shape up your idea. And then you have to identify the applicable and adequate material. You can come out with a variety of material, set on your table, but you have to come up only one. You have to select only few of them, but make a good selection that the material you are selecting, they will definitely be applicable and suitable for the accomplishment of your design. And then the thing is, after making the selection of the adequate material, now you have to assess your adequate material, the one that you have chosen, you have found ready to do the job. You have to assess it according to your design, according to your conceptual modeling, according to your vision. Will it fit with that material? Will be methodically working for you or not? And then you will finally decide to say, this is the one that I'm selecting, and these are the material suitable, feasible, and reliable to the purpose I'm going to accomplish for my project, which is still a vision to turn into a reality. Among many, we have selected a few necessary criteria an engineer and architect should be aware while choosing the material for a specific project. We listed the availability. The material is to be available enough for the design, or the construction element that you've designed. The material has to be durable. Durability is one of the key that enhance the value of a product. And there's as well the climate, as we said it earlier. And there's a cost per unit, the cost of your material. Most of us, we tend to design. We go ahead doing the material selection, but in most of the cases, forget the cost of material. Cost plays a role in the full process of designing a product. You have to select material according to their cost as well, unit cost, and a package cost. It helps. I guarantee you, it helps. Otherwise, you will be changing design one after another, and it's a time waste. And there's as well the performance in properties. We talk about physical properties, chemical properties, or geological properties. Those are the properties linked to the material you will be selecting. And it comes sustainability. Sustainability, it's very important. If your material is not sustainable, nobody's gonna buy it. If your material cannot sustain, or fulfill somebody's desire, the buyer or the seller, trust me, even you come up with a good design, the one that has never been made, remember that it's never gonna be bought. It's not gonna be a sustainable product, because there's no sustainability in it. So sustainability is one of the key, and we're having the aesthetic and the usability appeal parts. So the aesthetic, it's all about the beauty. We all know aesthetic. It's all about the beauty. It's all about the out, shape. It's all about how it matches and fit with the environment. And finally, we have the maintenance. That's it. Especially on a mechanical product, building a product that is the maintenance. It's definitely very important, especially in the mechanical engineering. When looking for various construction materials, the architect will realize that the rate varies extensively. As a rule of thumb, it's not always desirable to look for the most affordable products. One needs to take into account the lifespan of the material, or its utility, or its performance. When an architect buys substandard material, you may end up having to restore or to redo your work, because your material is a substandard, and your client might not like it anyway. So that's a waste of time. You have to go back again and come up with a new selection. But selecting a material that is affordable but not substandard, that really is a game changer. So to restore them often, and this ends up being costly, because if you take a substandard material, it might last for, let's say, 1 year or 2 years, but after each 2 years you have to buy a new one, the same material but a new one, because the one that was there is damaged, because it was not consistent enough. It was a substandard element. So preferring building materials that will serve you well for a long time. Choose the material that's definitely gonna, lesser your expenses, lesser the cost of your building material after years, lesser, your spending. Because if you choose a substandard material, remember one thing, like it or not, you're going to spend after the deterioration of that material, because it's not an original, it's a substandard. It's not a standard or super standard thing you bought. Because you didn't have much, you went for it, but at least jungle, with something that is kind of something that can level up your design and make your clients happy. That is very important when it comes to cost. Select a material will be cost effective to your selection. So the cost of material is one crucial factor while choosing materials for construction, as eventually it will safeguard your building. Climate. Another significant aspect of a selection of materials is the climate. Determinants like the average extent of heat or cold during the year, rain or snowfall, amount of daily light, needs ventilation are some points to consider. The construction material should respond to the climate and content. When climate appears in the picture, the characteristics of materials also evolve and help respond to the climate. As designers, we understand that the climate is one of the crucial elements, one of the crucial features that a designer or an architect or an engineer has to take into consideration for the good success to the accomplishment and realization of his product. If you want to know more about climate, just go watch our first video on the same topic. You'll find out what we spoke about the climate concerning the design of architectural buildings. Not only architecture, but it applies in all types or domains that exert their function into the designing environment. The sustainability of architectural or mechanical component comes into play primarily during design, and then it goes further to manufacturing and the disposal of the product. The material selection affects all of these stages of the life cycle of the product. In the design phase, sustainability considerations include strategies such as the use of low density materials. Very crucial, very important. Low density, it decreases the load of your building, especially for higher rise building. It's very, very important to pay attention to the material density, and somehow reduces the need of fillers, borders, part considerations, and down gauging. Manufacturing processes can also be tricked to reduce energy and water use, or low scrap generation, or volatile releases from secondary painting and adhesives. Therefore, we understand that in addition to finding the most cost-effective or highest performing material, architectural components, meaning that bricks or other components, including mechanical one, makers should also evaluate how it must be processed, how the material needs to process, how does it need to run, the duration of its sustainability, how will it fit into if it's a machine, how that component will fit into the machine, and it depends. There are a lot of criteria. The environment comes to play. Climate comes to play into it. The running time, the functioning time comes to play. So it englobes a lot of things, And the end of life is another stage where the material selection can contribute to sustainability. For instance, a readily recyclable material and avoidance of problematic adhesives, the aesthetics. Everyone has diverse tasks, specifications, and needs. Hence, if one person considers something charming and attractive, it may not interest the other. Only the architect and the client know about the quality of home, construction, building they need to design or live in. For instance, the type of flooring material you select can transform the look of the house or apartment. You select a flooring material that not only suits your tasks and tastes, but also fits into your budget, such as vitrifying tiles, ceramic tiles, granite, marble, stone, wood, etc. When choosing these elements, you need to consider the appearance you want. And remember that the choices you make, as well your budget, climate conditions, and various other factors will determine the material and the appearance or look of the building that you desired. Maintenance. The most suitable materials are those that are effortless or easy to maintain and manage. Maintenance will aid to preserve the building looking good and new for a long time. Good quality building materials normally require less maintenance than standard and cheap materials. One needs to study the life and quality of the building to ensure good construction. Maintenance is an important selection basis for building material because good materials are those which are easy and inexpensive to maintain. They add value to the building. Nowadays, architects and engineers must be able to design products that require less maintenance. A higher rate maintenance on a product requires a lot of effort and a considerable amount of money. And sometimes they become unaffordable for the client. Looking for ways to optimize the cost of maintenance during the design process is really a game changer for the architect's decision made and the client mitigation spend. Number 5, building element details. For this part, I selected some of my own product as an explanatory way of understanding. The image on the left is a sectional sketch detailing of a swimming pool structural layer composition. And the one on the right is a 3D OpenGeo image of the wall mounted and the pile wooden finish layer with steel connection support in creating detailing sketches. It was raining on that day. I was finding a way to take an element, a material that is wooden outside, maybe on the floor or on the wall, and I was thinking, okay, with this rain, how can I hang up, a wooden material outside? So I came up with this idea, of the 3D image you can see on your right side. I came up with a steel frame support and which I will be nailing or screwing wood on it and definitely scrolling them in a wall. So the idea behind this sketch, a weather shift from sunny to rainy. That is one of the ways I found idea, to implement my sketches. On the second image, it's still the same detailing sketches that I made, but now we're having different 3D OpenGeo images. One of a section cut and the other one of a crop region 3D representation. Image of a swimming pool. This one came up while sizing a flooring structure. So I came up with just a rough sketch detailing of a deck. Floor with wooden structural element supports sizes. And images on the right are just close range 3D OpenGeo images of the same deck that are designed with boundaries, settlement, and composition flow. This sketch illustrates a detailing of an environmental decorating serpentine element made of a wood material suspended with the help of hollow steel tube which welded to two mirrored steel buckets connection supports and a roof framing wooden steel connection. This element is set on a backyard corridor ceiling roof closer to a family gathering space. The idea was I wanted people who are seated in the gathering space to be wondered and so contemplative to at the sample tile element. I wanted something that will attract their attention. I wanted something that as they sit there, they can talk about it. You know, they can point it out. They can share even with their friend. You know, I wanted to make it to become and to really be a focal point for the occupancies. These are just meticulous sketches of an arbor wooden structure sizing element and a 3D OpenGL right on the left, which is a representation image of the arbor post for a connection wood and steel. In most of my sketches, let me make it clear, my design modeling, I don't really show my foundation, or either how's my post constitutes or my column, how is it made of. But I came up with an idea. I said to myself, why not, to show the sketch, of my footing. Why not, to present it out there, Maybe somebody will have another idea. So I came up with this, and just to show, what constitute my footing and the base plate. Yeah. And how is it made, type of element, how is the shape, the geometrical aspect of it. So I kind of selected some of my base plates in, of different kind, of course, to come up with descriptive views of different kinds, like this transversal section cut of a steel post. Actually, this is a project that I designed a few months ago with a populated interior. I used editing plans to crop the building and cut off a section of it. And these were the outcomes of the cropping region that I did on the building. On this last image, you can see a 3D OpenGL image of a wall mounted and a pile wooden finish layer with steel connection supports and a section cut off a gathering space, flashing out the position of the wooden decor fixed on the wall and other building elements. Composition including the cast shadow relative to the sun emplacement. In this, I just wanted to share a little bit of creativity, at the same time, a 3D image and a section of a typical environment that are created in this project. Finally, we have reached at our destination for today's lecturing session. Hope you are following around the critical points that I have enumerated, and you will definitely use them in your day-to-day work and projects. And remember that a good material selection is the key performance to the strength, stiffness, and stability of a good product. I, Jerush, will see you again in the next coming episode. Be safe, be sound, till we meet again. Cheers. It was definitely a huge experience, a great joy, and an exceptional moment.